Imagine waking up not to the gentle light of dawn, but to a profound, bone-shaking rumble that seems to come from the very core of the Earth. It's 2026, January 5th. Suddenly, news alerts flood every screen with an impossible headline. Every active volcano on the planet is erupting. From the snowy peaks of Mount Fuji in Japan to the fiery heart of Mount Nyiragongo in the Congo, the planet's geological pulse has synchronized into a single, cataclysmic beat. This isn't just a local disaster, it is a global event of unimaginable scale. The sky begins to darken not with night, but with something far more ominous, a testament to the raw power brewing beneath our feet. In the first hour, the world would be a planet of two vastly different realities. For the tens of millions of people living in the shadow of a volcano, survival would become a desperate, primal instinct. From Naples, Italy, Arequipa, Peru, the air would fill with the shriek of sirens and the thunderous boom of mountains tearing themselves apart. Pyroclastic flows, superheated avalanches, ash rock gas moving at hundreds of kilometers per hour, would incinerate everything in their path. These flows are unsurvivable, turning forests, homes, roads to ash in mere seconds. At the same time, monumental columns of ash, some reaching over 40 kilometers high, would punch through the sky, blotting out the sun and turning day into an impenetrable, suffocating night. By the end of the first week, the local disasters would begin to merge into a single global atmospheric crisis. The colossal plumes of ash and sulfur dioxide from the world's volcanoes, having been injected into the stratosphere, would be caught by the high-altitude jet streams. These powerful air currents, acting like planetary conveyor belts, would rapidly spread the volcanic aerosols around the globe. The initial plumes would coalesce into a vast, unified veil of haze, a translucent shroud wrapping the Earth. The once brilliant sun would appear as a dim, hazy disk in the sky, its life-giving warmth partially blocked. Sunsets and sunrises would become spectacular, fiery red spectacles, a beautiful yet terrifying sign of the pollution high above. This atmospheric veil would have an immediate and dramatic effect on weather patterns. The reduction in sunlight reaching the surface would cause temperatures to begin a noticeable downward trend. Section 4. Month 1. The Great Global Chill begins. 1 month into the global eruption, volcanic winter becomes a lived reality worldwide. The stratospheric sulfate aerosol layer is fully established. It reflects a large portion of incoming solar radiation back into space. Scientists confirm a measurable drop in average global temperature, 5 to 8 degrees Celsius. That change is larger and faster than the cooling that helped plunge Earth into the last ice age. Cooling is worst over the large continental land masses of the northern hemisphere. Rapid, sustained cooling triggers catastrophic failure of global agriculture. Growing seasons in temperate zones are cut short by unseasonal frosts and a persistent lack of sunlight. Staple crops, wheat, corn, rice, which feed billions, wither and die in the fields. Photosynthesis is severely inhibited by dim light. The world's food supply, already strained, faces complete collapse. Governments seize food stocks and force strict rationing. Oceans begin to show stress as surface waters cool. Meanwhile, CO2 and sulfur from eruptions cause rapid ocean acidification. Section 5. The first year. A world transformed. After 1 year, the planet would be an almost unrecognizable place, locked in the grip of a harsh volcanic winter. The global average temperature would have stabilized at a new, much lower baseline, creating conditions not seen on Earth for thousands of years. Vast ice sheets would begin to expand from the poles. Mountain glaciers would advance, grinding down valleys. Sea ice would cover large swaths of the northern oceans, even in summer. Ocean currents and weather patterns would be dramatically altered. The hydrological cycle would be fundamentally broken. Less evaporation from cooler oceans. Global precipitation would decrease significantly. leading to megadroughts across vast regions. Other areas would suffer persistent, frigid drizzle. Humanity engaged in a desperate fight for survival. The global population drastically reduced. Initial disasters, subsequent famines, disease, conflict. Survivors clustered in small, fortified communities, likely in equatorial regions, or in coastal areas where oceans moderate the cold. Section 6. Surviving the Volcanic Winter, Human Resilience and Adaptation. In the face of such an overwhelming catastrophe, the survival of the human species would depend on two key factors: our ingenuity, our ability to cooperate. The immediate post-eruption years would necessitate a radical shift in how we live, in how we generate energy, and in how we produce food. With the global power grid shattered and fuels hard to move and refine, energy production would become highly localized. Communities with access to geothermal energy, heat from the Earth's core, would have a significant advantage. Others would have to rely on small-scale wind, small hydro, or protected nuclear plants, providing precious electricity for heating and indoor farming. Food production would become the central organizing principle of society. Large-scale, sun-dependent agriculture would be impossible. The future of food would lie indoors, in vast, insulated greenhouses lit by energy-efficient LEDs. Hydroponic systems. Aeroponic systems would grow crops with minimal water and no soil. Research into genetically modified organisms would accelerate. Scientists racing to develop crops for low-light, low-temperature conditions. We would also cultivate previously overlooked sources, mushroom farms, protein-rich insect farms, adapting our diet to survive. Section 7. A New Dawn, Hope and Preparedness for a Changed Planet. The volcanic winter, though devastating, would not last forever. After 3 to 5 years, the majority of the stratospheric aerosols would have settled out of the atmosphere. The cleansing process would be gradual at first, but then accelerate. The first sign of recovery would be the sky itself, slowly shifting from a perpetual gray to a pale, watery blue. The sun, for years a dim ghost, would regain its strength, its rays once again warming the surface of the Earth. This moment, the true dawn of a new era, would be a profound and emotional event for the survivors, a powerful symbol of the planet's own resilience. As the planet slowly warms and the ice begins to retreat, the work of rebuilding civilization would begin in earnest. The survivors, hardened by years of hardship and armed with new technologies and a deeper sense of community, would be the architects of this new world. The focus would be on creating a society that is fundamentally more resilient and in tune with the planet's geological realities. This would mean decentralizing essential systems, investing in a diverse portfolio of underground and protected food production methods, and maintaining a global network for monitoring geological threats. We would carry the memory of the Great Eruption not as a scar, but as a defining lesson.